Okay, so today, since last time we already conclude our first chapter, so if you guys still have any question, you can always ask me lah about the first chapter. But today I would like to continue with chapter 2, which is about kinematic of linear motion. Are you guys ready?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Sempat makan tak?
Sempat.
Alas separuh je dulu.
Dapat je.
Belum.
Makan separuh je. Okay. Chapter 2 is about kinematic of linear motion. First of all, we go through the title first. Can somebody tell me what does it mean by kinematics?
Motion.
Okay, it's a motion. Okay, it's a study of motion. Correct. How about linear? What do you guys understand about linear?
A straight line.
It's a straight line. Okay, good, very good. Then how about motion? Motion is motion lah.
Movement.
Okay, motion tu ada pergerakan lah kan. Okay, so linear it could be straight line, it could be as long as it's berkadar langsung, that one is actually a linear lah. Okay, so maybe we can conclude that this one is actually a study of motion. Oops, buruk sangat tulisan So study of motion. Okay, before we go further into this topic, I would like to ask you guys a question. So let's say you try to imagine the situation. Let's say you are inside a car, you are sitting behind and your parents is driving, and then maybe you are holding your phone. Okay, and then at a certain time you want to release your phone, you drop your phone again. And then when you drop, where do you expect the phone will be? Is it going backwards? Is it fall straight downwards? Is it goes forward?
Backward.
Okay,
Forward.
lain?
Forward.
Forward. Okay, lain? Apa saya buat ni? Okay, katakan kamu akan check. Okay, now you are holding the phone and then you are dropping the phone. Okay, drop phone. Okay, ada yang cakap dia jatuh forward, backwards. Lagi? Apa jawapan ada?
Downwards, sir.
Downward straight ke apa?
Yes.
Okay, so the velocity is constant. So ada cakap tadi, saya ada dengar backwards. Ada kata downwards straight. Ada tak yang cakap forward? Ada?
Tak ada, sir.
Tak ada. Okay, so saya ada backwards or downwards kan? Okay. Another example, let's say now you open the window, okay, and then you put the phone outside and then you release your phone. So where do you expect your phone to be? Will it go backwards or will it go straight downwards?
Straight downward.
Straight downwards. So now you open the door, open the windows. Okay, lagi? What else? Kemana? Ada yang cakap dia pergi belakang?
Dia ke belakang.
Dia ke belakang. Okay. Belakang maybe macam tu kot. Okay, so now for those yang cakap inside the car downwards, kenapa kamu cakap dia downwards?
Sebab mungkin waktu dalam kereta tu tak ada force, so dia jatuh direct je.
Okay, okay, good.
Waktu yang luar kereta tu kan angin kuat kan, so
Okay.
terus ke belakang.
Tapi angin tu sebab apa datang? Ada kalau kamu, let's say kamu berdiri kat tepi jalan kan, angin tu kuat tak? Mudah dipengaruh rupanya. Okay. Kalau yang dalam kereta tu macam mana? Yang kata jatuh ke belakang dalam kereta, kenapa?
Sebab kita tengah bergerak.
Kita tengah gerak, okay, so bila kita jatuh, dia pergi belakang. Sebab apa? Sebab phone tu tak gerak.
Inertia.
Okay, lagi. Ya, kalau yang kat luar tu, Dia jatuh, dia straight ke bawah. Kenapa?
Sebab kereta tu bergerak dan benda tu in constant, dia tak bergerak.
Okay. Okay, interesting. Okay, so lagi satu example. I give you another example. Okay, let's say now, sekarang ni kat sebelah saya ni ada satu kotak songkok. Nampak? Kotak songkok kan? Kau tahu tak songkok macam mana? Di kotak dia tu, let's say saya ada satu kotak songkok, and then satu lagi songkok dia itself. Okay. Let's say the kotak songkok tu obviously lagi mass dia lagi kurang lah. So obviously M1 is less than M2. So when you release at the same time, which one will reach the ground first?
M2.
M2
Okay,
kot.
M2 kot. Lagi?
Sama.
Sama. Lagi?
Serentak.
Okay. Lagi? Ada yang cakap M2 dulu? M1 dulu? Tak ada. So, ada yang cakap M2, yang cakap same time. Okay, yang cakap M2 kenapa? Sebab dia berat, dia jatuh dulu.
Ya, betul.
Yang cakap M1? Yang cakap serentak tu?
Sebab kalau tak ada rintangan angin, kalau dalam situation vacuum, dia memang akan jatuh sekali. Okay.
Kalau katakanlah kamu dekat dia katakanlah kamu dekat bangunan 2 tingkat, 4 tingkat lah, 4 tingkat, bangunan 4 tingkat. Ada seekor gajah dengan seekor kucing. Dua-dua lompat. Mana sampai dulu?
Gajah.
Gajah.
Gajah dulu sampai.
Gajah.
Sampai dulu. Kenapa? Sebab dia berat.
Sebab dia lompat tak tinggi.
Basically sebab dia berat lah.
Tinggi, so dia lambat-lambat. Okay, interesting. Okay, anyway, so this chapter we discuss about the motion, and hopefully by the end of this chapter you get the answer for this situation. So, saya tak nak kasih jawapan. Maybe you can try later on. Okay, jangan campak kucing kamu. But maybe you can try lah, especially yang the one inside the car tu, bila boleh keluar rumah lah. Anyway, so actually kalau chapter ni, basically if you can have some information like the initial position, initial velocity and the direction, and you can basically predict the end results, like which one will come first, which one will be faster, and so on. So this is the importance of this chapter lah dalam dunia sebenar. Okay, apa saya nak cakap? Tak ada apa. Okay. So if you going back to the learning outcomes, this chapter actually define certain things. You need to be able to define things like velocity, acceleration. Okay. Both of these you need to be able to differentiate what is average. Okay, I'm gonna write instantaneous first. And what is actually average. Okay, so class, what is the instantaneous velocity? Let's say we are talking about velocity first. Can somebody tell me what is the definition for instantaneous velocity? What does it mean by instant velocity?
Velocity at certain point.
At certain point, okay, very good. Lain? Ada yang nak tambah? Tak ada, okay. So instantaneous tu at that particular point. So at that particular point, berapa velocity dia? So that's the idea lah. How about the average?
Rate of change of the displacement.
Okay, rate of change of displacement. Okay, lain? Siapa nak tambah lagi? Dalam bahasa yang mudah sikit. Sama nak cukup nak ingat rate. Hasif?
Time interval.
Time interval. Okay, kenapa dengan time interval?
Average.
Average, okay. Okay, good. Okay, so ada few answer and few trying, and the thing is itu adalah more to dia punya definition dalam bentuk word. Tapi untuk faham sama, to really knows whether you understand or not, the only way to tell is that if you can tell the physical difference between instantaneous and average. Okay, let's give you an example. Okay, let's see if I have apa dia, semut, ants. Semut hijau Okay, this ants is traveling from point A okay, they travel to point B and then eventually to point C. The same ends, the same end. Okay. When it start at point A, the velocity is at, let's say, u equals to, okay, I use the same symbol first, v equals to 1 meter per second. Okay. At point B, the ants start to run. Running sikit, maybe dia jadi 2 meter per second. Start lari ya, tambah sikit. Okay, let's say this one is 5 meter per second. And at point C, dia dah penat, so maybe they slow down a little bit. So V is equals to 3 meter per second. Okay, so obviously the velocity keeps on changing lah. And then throughout the time, so the total this ant travels from A to point C, let's say they covered 15 meter je. 15 meter bagi kita sikit lah, bagi semut tu maybe besar. Yeah. So the time taken maybe about 3 minutes. Okay. So now my question is, what is the instantaneous velocity at point B?
Five.
Okay. Ada jawapan lain? Anyone has a different answer? Nurin? Oh, sorry, Muklisa? Rasa apa?
5.
5, okay. Okay. I think most of you guys will think it's a 5, huh? Okay, how about the average? So, what is the average velocity during the journey of the ants from A to C?
Displacement divide by time. So
Displacement divide by time. Lagi?
0.83.
0.8. Oh, terus kira. Wow. Let saya check apa benda yang dikira tu. Cuba kamu boleh cakap sikit. Madi, kamu kira apa sebenarnya? Laju sangat. Apa yang kamu kira? Oh, 0.083 tu apa? Apa nilai apa?
Total displacement
Okay.
divide total time taken.
Okay. Very good. Lain? Fatimah?
Yes, sir.
Kamu rasa macam mana nak kira? Average velocity.
Saya kira sama macam Mahdi tadi.
Sama macam Madi. Nes? Nes dah ada. Hi Nes.
Hai sir, sama juga sir. Dapat jawapan
juga.
sama.
Okay. Terus kira kamu dahsyat. Sekejap So tengok Alisa dah ada tak?
Ada sir.
Ada. Okay. And then Syahira ada?
Ada sir.
Alright, okay, good. So everyone attend this class. Okay, so I think you guys get the idea lah. So V average is basically total displacement divided by total time, which is 15 meter divided by 180 second. This is where you get 0.083 ms minus 1. Okay, correct me if I'm wrong. Okay, so if you're going back to the definition, so this one is correct. Very good. Very nice. So I think you guys can differentiate between those things. So by definition, okay. So definition dia ada dua lah. Satu yang wordings tadi tu. Tapi saya nak cuba tengok yang apa tu, writings. Sorry, formula. So V instantaneous is ds over dt. V average is basically delta s over delta t. Or to be exact, it would be S final minus S initial over T final minus T initial. Okay. Okay, now my question is, what does it mean by dsdt? Apa maksud dsdt tu? Kalau macam tadi, they give you example like this and like a diagram. So you know that the velocity here is that lah, the 5. So yang dsdt ni apa sebenarnya? dsdt kalau kamu nampak benda tu, kamu teringat apa sebenarnya?
Differentiate.
Differentiate. Okay, good, very good. Okay, so betul, dia ada differentiate. Okay, so this one is actually differentiate. Okay, ada lagi satu, it is actually a gradient. Okay, gradient kalau dia kasih graph, differentiate kalau dia kasih equation. So in fact, dalam exam kamu, they could ask you 3 form of questions lah. Ada 3 bentuk soalan yang dia boleh kasih untuk chapter ni. Maybe dia akan kasih dalam 2 bentuk. Satu tu dia tak kasih. Number 1, dia maybe boleh kasih dalam bentuk sentence macam ni. Ni lukisan kan? So dia kasih dalam jalan cerita lah. So bila dia kasih jalan cerita tu, kamu boleh lukis diagram so that you boleh dapatkan results macam ni and you can calculate. Okay, satu bentuk soalan. So types of question, form types. Ini untuk exam saya cakap. So number 1, they could give you a storyline. From the storyline, you can try to describe the situation. Maybe you can draw, and then you can deduce more information and so on. Okay. Type number 2 is that they give you equation. And types number 3, they will give you a graph. Okay. So for the first type ni, we already covered lah. So yang macam yang tadi saya tunjuk tu, cuma saya cerita tu, maybe tak adalah soalan macam tu kan. Later, we see about this equation. And then kalau sempat kita masuk graph. I don't think so, but maybe sempat, maybe not. I'm not sure. Okay, how about okay, session tak apalah. Kita buat velocity je. Kita buat yang senang je dulu. Okay, now let's say if you want to see equation punya type question. Okay, so given that calculate maybe saya boleh tak apalah, boleh lah, tukar sikit boleh, I change to minus 3. Okay, B velocity Okay. So this is the question. Let's say this is we are talking about an object. Kisahlah objek ke apa, a car ke, a person ke apa. Given that the equation of motion, yang ni dipanggil equation of motion, can be described with this equation. Calculate the displacement after 3 seconds, velocity at 5 seconds, average velocity from 2 to 3 seconds, and acceleration at 3 seconds. So how do I solve this one? So let's say we start with question A. How do I find the displacement after 3 seconds?
Masukkan 3 second dalam T.
Okay, masukkan 3 second nanti.
Lepas tu seri je S.
Lepas tu, kira.
Ya, betul.
Putri, what do you think? Shaden?
Not sure lah also.
Not sure. Okay, it's okay. Shaki?
I think same like Balkis.
Okay, Shaki kata sama macam Balkis. Okay, and yes, the correct method would be replacing this ataupun substituting 3 seconds into the equation. So given that S is equals to 10t square plus 5t minus 3, betul tak? Okay, so what you need to do when t equals to 3 ni, kalau mathematics tulis lah, tapi physics tak tulis sangat kot, so saya padam lah, you don't have to. When t is equals to 3, so it becomes 3 square plus 5, 3 minus 3. So you end up with 90 plus 15 minus 3, which is 102 meter. Betul ke tak?
Sama sesama.
Betul, sir.
Okay. Okay, maksudnya apa? Katakan saya ada objek ni. Katakan this is a person lah. Okay. This is when t is equals to 0. After 3 second, person tu dekat mana?
Dekat 102 meter daripada yang asal.
1-2 meter. Okay. Kanan ke kiri?
Kanan.
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 Why?
Positif.
Positif.
Yes.
Positif.
Very good. Okay. If you look at this equation, dia ada negatif kat sini tau. So that means for a few second, I think split second was, but 3 second pun dia dah kat sini. I think for split second, maybe dia ada dekat sini sekejap. And then dia patah balik ke sana. Okay. So this one, equation of motion, if you calculate the S, ada possibilities that you can get negative. Boleh dapat negatif. Doesn't matter. Kalau dapat negatif, it means that it travels to the left. Itu je. Kamu jangan stick dengan apa yang kamu belajar kat sekolah. Okay, jarak tak ada negatif. No, this is not a distance. This is a displacement. So, negative means to the left. Positive means to the right. Ataupun upwards, downwards. Itu dia terbang pula kan. Okay, anyway, yang B pula. What is the velocity at 5 seconds? Ini dia tak cakap pun, dia nak instantaneous ke dia nak average. So ini instantaneous ke average?
Instantaneous.
Kenapa?
Sebab dia cakap 5 second je.
Okay. Syaira, okay.
Okay, sir.
So ini adalah average ke instantaneous? Velocity.
Instantaneous velocity.
Okay, so kalau kamu cakap instantaneous, so macam mana nak selesaikan dia? Syafiq?
Yes, sir.
Macam mana kita nak kira 5 second, at 5 second, velocity dia berapa? Dia beri maklumat ini je.
tadi kan dah kira displacement.
Okay.
Kita boleh pakai formula V equal to delta S over delta T, substitute 102 over 5 second. Then kita dapat velocity dia.
Okay, it's a good try, it's a really good try. That one kita calculate velocity. Tapi velocity apa sebenarnya tu? Firas.
Yes, sir.
So kalau kita kira macam Syafiq buat tadi, kita kira V apa sebenarnya? Syafiq kata cara nak kira velocity, kita masukkan nilai 5 second tu kan, lepas tu dia dapat displacement, lepas tu dia tolak dengan 0, dia bagi time.
Tak ada idea rasa.
Tak ada idea. It's okay, don't worry.
Tak ada idea.
Okay. Fidai. Okay, saya bukan apa. Saya nak I really want you guys to understand the difference between instantaneous dengan average. So, kita tahu soalan dia sekarang ni nak instantaneous. So, dia kata dia cari velocity at 5 second. Memang dia kata at 5 second lah. Dia tak ada range, tak ada period ke apa. So, we know that this one is instantaneous. Tapi, in terms of calculation, boleh tak kamu bezakan? Anyone else want to try? Ada siapa nak cuba lagi? Asif?
Yes, sir.
Ada nak cuba tak? Macam mana kita nak kira instantaneous velocity?
Tak pasti ya.
Tak pasti. Okay, it's okay. Don't worry. Okay, we're going back to the
Sir, kalau kita buat pembezaan untuk equation S tu boleh ke?
boleh?
So nanti jadi 20T tambah 5.
Okay, betul? Okay, exactly like that. Okay, we're going back to the, okay, thank you, Mukisa. We're going back to the definition. Okay, kalau kamu confused, always tengok balik definition lah. So, dalam exam, ini memang common cases. Even time exam pun student sampai exam dia still confused average dengan instantaneous. Dia faham soalan apa, tapi bila kira dia tak sure nak buat yang mana. Okay, so if we're going back to the definition, ini dengan ini ada beza tau. Okay, so kalau average, that means kamu kena cari final, initial, time. Okay, tapi kalau dia nak instantaneous, you really need to differentiate ataupun take the gradient. Okay, cara lain macam yang soalan tadi tu memang diberi, soalan ini tak diberi. So kalau kamu nak differentiate, make sure dia diberikan equation. Okay, biasa memang equation diberi lah. Okay, so what you need to do first, you differentiate. So V equals to ds over dt. Ini dia punya formula dia, tapi sebenarnya kamu boleh tulis macam ni, d over dt, kamu differentiatekan s. Okay, so ini memang macam maths lah, bukan macam ini, memang maths. So it's a 10t square. Saya belum differentiate lagi, so just tulis dia. Okay, and then bila kita differentiate, according to Mukisa tadi, dia kata dia jadi 20t tambah 5 minus 0. So, we left with that one lah. So, this one, you guys still remember tak macam mana nak differentiate? Ingat lagi tak?
Ingat saya ingat.
sir.
Okay, bagi yang tak ingat tak apalah. Saya assume ada yang tak ingat. So, kalau dah ingat tu, kita recap je. Okay, yang dua ni, kita bawa turun. Okay, bila bawa turun ni, dia multiply dengan yang pemalar depan ni lah, jadi 20. Okay, yang atas ni pula kita tolak 1. So 2 tolak 1 tinggal 1. So 1 ni kita tak tulis lah, kuasa 1 kan. And then yang 5t ni, di sini ada t kuasa 1. 1 ni bawa depan, so 1 darab 5 dia kekal 5. Okay, t kuasa 1 tadi tolak 1, dia jadi t kuasa 0. So t to power of 0 basically is a 1. So 5 multiplied by 1 is 5. So that's why we end up like this. Okay, dan ni dia tak ada pemalar, so dia hilang. Sorry, tak ada variable. Pemalar tu constant, variable lah, sorry. Okay, now this is the general equation for velocity. Okay, that means given any time, I can straight away know the velocity. So soalan dia kata cari bila 5 seconds. So when t is equals to 5 seconds, I can write 20 multiplied by 5 plus 5, I should get 100. Right. Betul tak? Betul tu blur tak? Okay, you guys agree with this? Setuju? Tak setuju? Bantahan? Okay.
Setuju sir, setuju.
Okay.
Setuju.
Setuju.
Alright. Any question tak so far?
No question.
Tak ada madam. Tak ada sir.
Boleh, tak apa. Madam okay. Okay, kalau kamu perasan, saya memang go slow lah, especially untuk ni sebab this is a basic and I really want you guys to understand. So kalau ada tak faham, cakap je, don't worry. Kalau nak perlu ulang, kita ulang. Tak ada masalah. Okay, now, kalau tak ada soalan, kita go further. So, question number C, they want to find the average velocity from 2 to 3 seconds. Saya tukarlah 2 to 3 seconds, macam pendek sangat pula. Sorry. 1 to 3 seconds. Oops. Apakah ini? Mana soalan tadi? Okay. Okay. Salah kelas. Okay, anyway. 1 to 3 seconds. Average velocity from 1 to 3 seconds. How do I calculate?
No formula.
Okay, macam mana?
S2 minus 1 over T2 minus T1. Kan?
Sorry, Asif. So macam ni kamu nak kira?
Guna average, formula average velocity tu.
Okay, so kamu kira dia punya apa dulu?
Displacement.
Okay, displacement bila time equals to berapa?
One dengan 3.
Okay, 1 dengan 3. So macam mana kita nak kira displacement, kita substitute je lah kan?
Ya.
So kita pergi balik. Okay, kamu jangan confuse jangan terambil yang ni pula. Kalau ini adalah equation velocity. So we go upwards. So this one kat atas tadi lah. This, kita pergi balik kat sini. Ini adalah equation for displacement. Kita masukkan nilai-nilai tersebut. So it becomes 10 3 square plus 5 3 minus, saya lupa, 3. Okay. Ni kita dah kira kan? So jadi 102. Betul kan?
Betul.
And then we have 1 plus 5, 1 minus 3. This one is equals to 12.
Yeah.
Okay. That means my delta V average equals to delta S over delta T, which is basically S final minus S initial over period of time, which is T final minus T initial lah. So I got 90 divided by 2, which is 45.
45.
Okay, good, very good. Okay, so common mistake student would be is that dia terlupa nak kira initial punya displacement. So they assume that this one is 0 ataupun the times is 0. Students dia suka nak assume sebab dia cepat kot. So dia terassume yang tu 0 tapi sebenarnya tak. So be careful with that. Okay, C settle, now D. Acceleration at 3 seconds. Okay. So dia nak average ke dia nak instantaneous?
Instantaneous.
Okay, so macam mana nak kira?
ES over DT.
Apa?
Kita differentiate 2 kali.
Differentiate 2 kali. Okay. Lain? Betul lah tu. Differentiate 2 kali. Cuba buat.
AV over DT.
Okay, dV over dt. Correct. Okay. So yang D tu, kalau kita nak cek A instantaneous is equals to, dia adalah dV over dt. Mana nak dapat dV dt ni? Sebenarnya kita kena differentiate 2 kali ds dt. Okay, tapi sebab kamu dah differentiate tadi sekali, so jangan buat banyak kali pula. So what you need to do is that you can differentiate d dt v tu. So equation for velocity kita dah ada 20t plus 5. So dia jadi apa ni?
20.
20 ms minus 2. Okay, unit. Jangan salah pula. Okay, what does it mean by 20 ms minus 2 tu? Adakah dia accelerates, decelerates, constant?
Dia accelerate.
Accelerates. Kalau accelerates maksudnya objek tu memecut lah kan?
Memecut.
Ya.
Okay. Katakan ditanya lagi satu soalan. Calculate the average acceleration. Macam mana? Okay, kalau kita nak cari average velocity, kita buat delta S over delta T. Correct or not?
Yes.
Yeah.
Correct.
So, A average basically will be delta V over delta T. Can you guys agree with this or no?
Agree.
Agree.
Yes.
Okay, so if you want to find the average from 1 to 5, you have to use this formula. So, which means you have to find my V final minus with my V initial divided by the total time, which is T final minus T initial. So I'm going to write down the velocity punya equation ni. Okay, so ikut kat sini. Okay, that means I have to substitute when T is equals to 5 and when T is equals to 1. Katakan kita substitute. Okay, kita buat asing-asing lah. Kita kira dulu. Okay, V at 5 and Vt equals to 1. Okay, ini 25. Okay, betul?
Betul.
Betul, sir.
So, A average is equals to 105 minus 25 divided by 5 minus 1, which turns out to be 80 divided by 4, which is 20.
20.
So, the average acceleration is 20. The instantaneous acceleration is 20. Make sense ke tak? Masuk akal ke tak? Pelik ke tak pelik?
Tak.
Tak pelik. Okay, so tak pelik. Apa punya soalan pun saya tak tahu. Saya pun tak tahu kenapa saya tanya pelik ke tak pelik. Okay, anyway. Katakan 20 meter per second tu maksudnya 20 meter per second ni, kalau kamu tengok, lepas kamu differentiate dia 2 kali, dia tak ada dependence dengan time pun sebenarnya. If you notice, once you differentiate dia twice, ni kan dekat sini kamu differentiate yang kali kedua ni, you left with 20 je. There's no variables at all. So it means that the acceleration is constant. Acceleration tu tak berubah. Daripada awal cerita sampai akhir cerita, acceleration dia sentiasa 20. So this final answer actually agrees with that situation lah, because average dia adalah 20, which makes sense lah, because it doesn't even change in acceleration. Acceleration is constant. Okay, now just want to point out a little bit about uniform acceleration. Okay, what does it mean by uniform acceleration?
Constant
Yes, acceleration is constant. Okay, so for your syllabus, all acceleration is constant. Acceleration tak berubah. Okay, how about my velocity? Does velocity change or not? Kalau acceleration constant, velocity berubah ke tak?
Velocity pun constant.
Berubah. Baik. Boleh tak saya punya acceleration constant, velocity pun constant? Macam pening. Okay, saya tulis.
Kalau acceleration dia kosong,
Kalau acceleration constant kosong, so
velocity dia
velocity
tak
dia
berubah.
exactly. Memang betul, exactly. So acceleration constant, it could be any numbers, it could be any numbers, and also it could be zero. Zero also considered as constant acceleration. So when acceleration is zero, the velocity is constant. Kalau any numbers, so velocity changes. Okay, yang lain boleh ikut ke tak? So far.
Boleh.
Boleh.
Boleh, sir.
Nice, okay.
Okay, sir.
Okay. So bila acceleration is zero, velocity is constant. My question is, adakah velocity itu zero?
Tidak.
Ataupun tidak? Syairah, what do you think? Bila acceleration zero, velocity constant, adakah acceleration zero? Adakah objek? Apa saya cakap Adakah velocity itu zero? Maafkan saya.
Tak.
Tak. Dia tak semestinya. Velocity constant, dia masih lagi boleh zero, or it could be any numbers. Okay, kalau dia ada numbers other than zero, that means object is moving. Okay, kalau dia zero, that means object is stationary. Okay, so all of this is something that you need to look on lah. So kamu kena faham dia punya definition, tapi not by word. I mean, definition by word is important because maybe dia tanya dekat dalam UPS, but then yang lebih penting, you understand the physical meaning. Contohnya uniform acceleration, constant acceleration, constant velocity. Velocity is zero, object is stationary. Dia biasanya dikasih situation, macam contoh dia kata initially the object is at rest, so it means that the velocity is zero. Itu maksudnya. So going back to this our situation over here, tadi kita dah tengok bila as the time increase from 0 to 3, this person actually moves to the right. Okay, what can we say about the velocity? Kata kita ambil case ini, contoh velocity dia daripada 1 to 3, kita ada 1 to 3 second. Okay, contoh so this is the person, this is when t is equals to 0. Okay. This is the person when t is equals to 1, and this is the same person when t is equals to 3 seconds. Okay, based on the numbers below that you already calculate, kita dah kira kita tak kira ni. Sorry. Ni kita kira velocity dia. Saya ambil balik. Saya ambil gambar ni sebab yang ni kita tak kira velocity, but we calculate the velocity down here actually. Okay. So instead of 1 and 3, we have 1 and 5. Okay, so maksudnya bila dia 1 saat, velocity dia berapa?
25.
25. Ke mana direction dia?
Right.
Kenapa?
Sebab dia
Positive.
positif.
Okay, good, very good. Okay, when the t is equals to 5 second, dia ada 105. So direction dia ke mana?
Ke kanan.
Okay, stay to the right. Okay, and then how about the difference? Is it accelerates? Adakah objek tu accelerates ataupun decelerates?
Objek
Daripada 1 ke
accelerate.
5? Yes, sebab the increase in the velocity. Okay, when t is equals to 0, adakah objek tu stationary ataupun adakah objek tu moving?
Stationary.
Apa? Tak dengar. When t is equals to 0, does the object moving or stationary?
Stationary.
Okay. Fadila cakap apa tadi? Tak dengar Fadila.
Stationary.
Stationary, okay. Syaira macam nak cakap. Lepas tu dia tak cakap. Nak cakap ke?
Sir, kalau ganti ada
Saya
5.
kira moving, sir.
Moving lah.
Kenapa?
Sebab kalau masuk dalam equation tu, kita akan dapat 5 meter per second.
Yes, exactly. Okay, good. Very good, very good. Okay, tak apa. When we substitute this equation, okay, ini adalah equation V tadi tu lah, di atas ni. When t is equals to 0, the object is actually moving because we still get V equals to 5. Okay, so that means it still moves to the right, but initially it's not that fast lah. And then the person accelerates from 5 meter per second to 105 meter per second. So this is the physical meaning. Kenapa benda-benda ni penting? Sebab the next topic kita akan belajar pasal graph. The graph ni, the only way you want to understand if and only if you can understand the physical situation. Jangan takut dengan graph ni, sebab dia dah sangat simple. Kalau kamu faham konsep yang tadi kita bincang, sepatutnya tak ada masalah. Okay, so I will give you this graph as your task for the weekend. So what I want you guys to do is that I want you guys to describe the motion dekat tepi ni. So contoh dekat sini, for graph S lawan T ni kan, example, what can you say about the person punya displacement? Okay, contoh kita ambil satu contoh straight, kita buat terus. Okay, untuk example yang pertama tu, katakan kita ada objek. Objek tu bergerak ke tak?
Objek tu bergerak.
Kenapa?
Sebab dia punya displacement bertambah.
Ke kanan ke kiri?
Ke kanan.
Kanan. Yang lain?
Kanan, sir.
Kanan. Okay, how about the velocity?
Velocity saya rasa dia constant.
Constant. Kenapa?
Sebab gradient dia tu constant.
Very good. Very good. Okay. Yang tak nampak lagi, jangan risau, jangan susah hati. I'm not gonna give you answer yet. Okay, what you guys gonna have to do is that tengok nota kamu balik. Cuba bagi saya lah kan, bila kamu baca, dia susah nak faham. The only way kamu nak buat benda ni dengan senang and kamu akan ingat sampai exam is that kalau kamu faham and bayangkan. So really need to imagine lah. Cuba bayangkan kamu sebagai that object and this is you. Bila time naik, displacement kamu naik. Contohnya daripada sini 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, semua positif. Sebab tu kamu boleh cakap objek tu bergerak ke kanan. Okay, and then you can see that the increase is actually linear. So when the increase is linear, you can conclude that the velocity is equals to 0. Sorry, velocity is constant. Okay, so kalau velocity is constant, maksudnya velocity tak berubah. Acceleration dia adalah
0.
yes, that's why kita ada kat sini. Okay, so benda ni jalan cerita macam ni lah sebenarnya. So cuba tengok, cuba describe dia punya objek tu in terms of physical meaning. Nanti minggu depan kita akan discuss. So tak perlu submit ke apa, just that I want you guys to write notes over there. You don't have to print ke apa, tak perlu pun. Tapi kalau kamu lukis balik, okay lah. Kalau tak nak print balik boleh. Nanti saya kasih PDF. Okay, any question?
No sir.
Okay, tak ada soalan, kita berhenti sini lah. Okay, okay, thank you everyone. I see you guys next week.